Firstly, thanks everyone for joining us today. We're going to be talking about one of the slightly more nuanced problems that we have at Depop and how we kind of moderate for that within chat and our approach to that problem. So a bit about Depop. Firstly, we're a fashion marketplace of over 20 million users. We're in 147 countries. We're very proud to say that in the UK, 1 in 3 Gen Zs are registered with us. And we are largely a resale platform. So our inventory consists of a lot of secondhand, vintage or bespoke items. And we have a team of over 300 people spread across several offices, but our main HQ is in London. So of those 300 people are myself and my colleague, Odi. We are both data scientists in the trust and safety team. So we look at things like hacking, scams, abuse, and try to surface those to our moderation agents. And then what happens there is they action those accordingly. So warning or banning users. So just to provide some context, Depop is a very community-driven platform. This means that users basically interact a lot through messages, and they'll be discussing items in the message. So they'll be discussing like item quality, item price. It's kind of one of the main user behaviors of Depop. And the way that we make money as well is we charge a 10% fee for providing the discovery and sale of the items on the platform. Payments in Depop are facilitated largely by PayPal and Stripe, and this provides the protection for the buyer. So unfortunately, sometimes users, mostly sellers, try to circumvent our payment system by luring a buying party outside of the app. And this is mainly done through messages by providing some kind of incentive in terms of a reduction in price, but it can also be done through kind of listing descriptions or shop bios. So this is very, very dangerous for our buyers if they pay through PayPal, friends and family, or if they pay through bank transfer, for instance. They have no buyer protection. This means that they're not guaranteed to get their money back from the seller if their item doesn't arrive. And you can see on the right here, like an example of where these kinds of interactions typically end up. Furthermore, it means that Depop missed their cut, and it also creates a large overhead for our community support agents to deal with and come and try and pick up the pieces of a transaction like this. So this is definitely something that we want to avoid happening. And before we had machine learning within the trust and safety team, we had a very kind of rudimentary approach, which consisted of some scripts which looked for certain keywords in messages and flagged and surfaced these messages to our moderation agents. So keywords such as bank transfer or PayPal would be used for this. As you can imagine, the main issue with this is that it results in an extremely high false positive rate. For instance, on the left, you can see a clearly out-of-app transaction, and on the right, you can see a completely innocuous one. The issue is if you're just naively looking for the word PayPal in a message, it's going to flag both of these kinds of transactions, create a lot of noise for our moderation agents to sift through. So it's something that definitely we wanted to improve upon. So we came up with this kind of machine learning approach that focused on the main 3 channels of out of app that we'd identified. So these are messages, these are shop bios, so like which are basically a small description of a shop that a seller provides on their profile, and the actual listing description itself. All three of these are machine learning models. Shop bios is very simple model, like a random forest with TF-IDF. Listing descriptions is slightly more complex, but we think the most interesting and also the most complex model that we used was for messages. So for the purpose of this talk, we're going to focus on that today. So with messages, we had certain requirements. For instance, our model needed to run and flag out of app messages in real time. This is because we need to give the agents a chance to intervene in the transaction as it's happening. We don't think it's as effective to kind of retroactively tell a seller or a buyer that they shouldn't have been doing that, like once it's happened, because the damage is already done by that point. With this, we need to be able to handle a very large throughput of messages. So sometimes we're getting over 2 million messages through the app each day, and we need to moderate all of these in real time. Further to this, we need to detect the first out-of-app message in a conversation. So this gives our moderation agents a chance, again, to intervene while it's happening. We need a generic architecture that can integrate with downstream tooling, so it can be, so our model's predictions can be ingested by various services or be used by various tools that our agents use. And then we have some benchmarks for machine learning models at Depop across the board, which are kind of 0.8 F1 score on the test set. And we want an 80% precision in the alerts being flagged to the agents, so that we're not essentially wasting their time with false positives. So at the start of this project, we undertook the rather gargantuan task of labeling over 20,000 messages. We collected these messages with keywords, but we avoided the mistake that was made with the keyword script. So we were still labeling on top of these keywords. And we found around 5% of these were out of app, and we always specifically labeled for the first out of app message in a conversation. So at this point, I'm gonna hand over to my colleague, Odie, who's gonna kind of deep dive into the technical details of this model.
Thanks, Leo. Okay, so I'm going to discuss roughly the architecture that we used for solving the out-of-app problem. Can you share the next slide, Leo? So we went for transformer type neural networks. And roughly what transformers are, they're a class of neural networks that use an encoder-decoder setup. So what this means is the encoder takes some input, represents that in some hidden state, and then the decoder takes the hidden representation and regenerates another input. They're a really interesting class of models and have seen wide use in problems like machine translation. So for example, translating from English to French, the encoder will take the English language text and represent that in some vector of numbers. That vector of numbers would then be passed to the decoder, which then generates a French representation of the English word. So they're pretty interesting things. But transformer networks sort of build on this by taking an attentive approach over a recurrent approach. Can you show the next slide, please, Leo? So what that means is, instead of each word depending on the previous word and processing inputs in sequence, like the example on the top there, attentive mechanisms sort of consume the entire message or the entire text at once and choose which parts to attend to. So basically they try and figure out what bits in the message should they pay attention to, what should they leave out. And it's a pretty effective way of working. Next slide, please. So we played around with a couple of transformer architectures and eventually settled for Bert. Bert is a special kind of transformer network in that it's actually only an encoder and doesn't have the decoder parts. The reason is because Bert is actually only used for generating representations of text. So there's no classification or any downstream task. All it does is give a distributed, discrete representation of some text data, and it kind of borrows or translates transfer learning, which is a concept popular in image recognition and computer vision, and brings the notion of transfer learning down to natural language processing. And transfer learning, for those not familiar, is basically a concept where a large, sophisticated model is trained on vast amounts of data and trained on a very generic task. This generic large model can then be fine-tuned and applied to a more specific downstream task. So an example of this is on a previous project, we were working on a model that would classify paintings. So given an image with a painting in it, it would tell you, oh, this is this painting and it's painted by this person. So how we solved that problem was we took ResNet, which is a really large CNN model, trained on the ImageNet dataset, and the ImageNet dataset is made of just literally tens of thousands of items, so like from dogs, cats, fridge, so it can tell these things apart. So we took the large ResNet model that was trained on all of those things and then fine-tuned it. So we leveraged all of that existing information and then made it more specific to the task of painting recognition, and that gave us some really good results. So it's kind of a similar concept, but down to NLP. And the Bert model we used was pre-trained on nearly 3.5 billion words from Wikipedia, which I thought I'd check, and it turns out that's around 66,000 fancy novels, which is a decent amount to read, so no small task. So the pre-trained Bert model comes in a bunch of different sizes. We went for the small size after experimentation, just for reasons such as like ease of productionization, fitting with our architecture, and sort of performance gains. We found that the small size was suitable for us. So we then took this pre-trained Bert model and fine-tuned it on our 20,000 messages, and that involved a bunch of steps in between. So the first thing we had to do is tokenize our input sequences, our input messages, into tokens to be consumed by Bert. Now, tokenization is basically this concept of you have a string of a sentence or a message or whatever, and you want to split that into separate tokens, where a token represents a concept. A token could be a word, it could be a phrase. It's just an individual concept that's broken down from the level of a whole sentence. So in the example, say we have a sentence, he eats strawberries. Tokenization based on spaces as the boundary character would give us he eats and strawberries as separate tokens. But we took a slightly more sophisticated approach to this, and we used something called word piece tokenizations. So we use these word piece tokenizations and word piece embeddings allow you to not just do this basic tokenization, but also split tokens into their subtokens. So in the example, he eats strawberries, it would split it, he eats strawberries, and then further split strawberries down to straw and berries. And this gives us two big advantages. And the first one is it reduces your vocabulary. So the amount of vocabulary that you have to store is less because you're not storing each compound word. You just need the set of root words from which you can construct any other word. So that gives big performance improvements, especially when you're working with deep learning models, which are usually quite compute intensive anyway and memory intensive. The second boon of word piece tokenization is the fact that you run into out of vocabulary errors much less. So I'll give you an example. Say we have he eats strawberries, we know that, and then we see another sentence that's he eats blueberries, but we've never encountered blueberries in the training set, only strawberries. But now with word piece tokenization, we would break the word blueberries down into blue and berries. So we still get some information out of that. We still get the knowledge that blueberries are related to berries. Whereas without the word piece tokenization, that would just be lost. So it just gives richer representations as well. So after tokenization, we added special tokens for for Bert. So we added the class of CLS token to the beginning of the input sequence and a SEP token to the end of the input sequence. So the class token is basically used for summarizing the entire sequence specifically for a classification task. So the hidden state associated with the CLS token can be just immediately passed into a classifier and it will work pretty well. The SEP token, on the other hand, is used to sum up the whole sentence, not necessarily for a classification task, but just for any generic reason. It also has a second or secondary purpose. So remember how I said Bert is actually not a classification model, but really a generic model for sentence representations. It can also be used for tasks like question answering, sentence entailment, relationship induction. So giving multiple sentences. For example, question answering, you're given two questions and two sentences and you want to get the relationship between them. So in that case, you would have the SEP token separate the two different sentences. And that way, Bert knows which part is for which sentence. But in our case of classification, all it serves is gives us a representation for the text. So once we've done all this pre-processing and tokenization, we connect Bert's output, which is sentence message representations, to a simple MLP model. Next slide, please. And that kind of looks like this, the image on the right. So what we have is this sort of architecture where a message comes in. An example there is send me 15 pounds of PayPal. That message is then is then tokenized first and then fed into Bert's. Bert then generates an embedding or the representation of the input sentence, which is passed to the MLP. And the simple MLP gives us a classification as whether it's out of app or not out of app. And the Bert model we used ended up having 12 encoder layers, and each encoder layer is made up of 6 attention layers. So in total, that's around 72 attention layers, which is pretty complex, pretty deep. So given the complexity of Bert, we opted for a simple downstream classifier. So our downstream MLP only had 1 layer with around 206 neurons. And when evaluated on the test set, we found an F1 of 0.82, which is pretty good. And we have this metric known as catch rate. So for context, a catch denotes when the model finds an out-of-app message or is able to intercept an out-of-app message at the point of initiation. So basically the idea there is as soon as there's a whiff of an out-of-app transaction about to go on, does the model catch it? And so the catch rate says that 74% of the time, the model is able to intercept that as soon as it's initiated, which is pretty good. And precision is 92%. Precision is basically just true positive rate, saying when the model says something is out of app, how often is it actually out of app? And that's important to us because remember, we're surfacing these flags or the things that our model flags as out of app are being surfaced to moderation agents. And we don't want to, just inundate them with loads of false positives. We want it to be as clean and as tight as possible. So, and we managed to do that with a pretty good precision. So now that we've built the model, we've tested the model, it seems to be working fine. Next step is putting it in production because we need to use it. And to do that, I'm just going to briefly explain, I guess, our backend architecture. So to start off with, I'm not sure how many people are familiar with RabbitMQ, but it's an asynchronous messaging system. And basically what that looks like is, say we have 2 programs. One program puts a message on the queue for another program to then pick up. So a program might, crunch some numbers, get some output. It puts that output on the queue, and another program that wants to use the output of the first one just picks it up off the queue. And it's a really powerful design paradigm that just really extends to a lot of different things, and we use it here at Depop. So when a user on the client, on the app, takes any action, the backend sort of is responsible for making these things happen. So in this particular scenario of sending messages, when a user sends a message, the backend takes that message and is responsible for making that message go to the right, the recipient, show up on the screen, all of those things. But in addition to that, the backend also publishes the message onto the queue. What this means is the message is now in the queue. Downstream, any service can then pick up that message from the queue, and that's where we come in with our model. We typically productionize our models as microservices in Amazon ECS. So our model service in ECS then realizes that a message has been put in the queue, picks that message up from the queue, classifies it, and then puts the output back on the queue. Now, what this means is the fact, because the output is on the queue again, any downstream service who wants to use or who cares about the model's classification can then go there and pick it up. Next slide, please. And that is in fact what happens. So once our model outputs the message onto the queue, we have a downstream application or an in-house application called Trust Platform. And it's an in-house tool that we've built that our trust and safety agents use to moderate the platform. So they get warnings and things through it. So they get alerts when users have done, things that violate terms and conditions, and they can action the users through here. So picture once the model has found someone to be guilty of out of app, it then raises an alert. And an agent with this tool open can then get the alert and action the user. So there you see, user warned, banned, ban on devices. They can then take the relevant actions or just investigate further. So yeah. And as with any project, you've got to learn some things. Nothing ever goes perfectly. And we came away with two big learnings. The first is expert labeling. So Leah already talked a little bit about how we did our labeling. It was 20,000 messages. We split that into 10,000 each, and he did some and I labeled some. Now, this is fine, but with human labeling, no two people are the same. So one person, I might say that something is out of app, but Leo's notion of what's out of app might be different from mine. So if we're both labeling this data, then there's going to be inconsistencies within the data. So things that one labeler thinks are out of app, the other labeler might not think about is out of app, and they both somehow get fed into the classifier, and that could cause some confusion. So I think it would be better to have experts with a unified policy and idea and an agreed notion of what is what, and have those people do the labeling. Secondly is the idea of democratized labeling, which so that's basically labeling with a voting system. So you have 3 or more labelers or 3 or more people label the same data. So say we have 10 examples, 3 people label all 10 of those examples, and we then compare the labels assigned by each person. So sometimes where there's disagreements, the majority vote is taken. And that way, that's interesting as well, because you can do some interesting analysis. You can find out what sort of data points are tricky, where you're seeing the most disagreements, where you're seeing the most agreements, things like that. How often certain labelers agree, basically inter-rater reliability. Loads of different metrics can come from that. And another one that I'd like to also, mention or give a shout out to is deep learning models, or specifically deep transformer networks, you really need GPUs to run them. They're quite painful to run without GPUs. I mean, you hear that a lot, but in practice, you really do feel that pain. So we had to do loads of optimizations to run it without GPUs, which is pretty interesting in itself. Next slide, please. And so that brings me to the final slide. Just want a little shameless plug. We're hiring in data science, but also across the business. So if anyone's interested, you could visit that link on the screen or reach out to either myself or Leah, and we can get the ball rolling from there. Thank you. Does anyone have any questions or?
All right, I'm back. Cheers, guys. I guess I'm back at the right time. There's nothing else to add there. I've not just jumped in and ruined the end or anything.
Good.
We're good. Man, that was wicked. Thank you very much, guys. If you've not done so already, I'll maybe just get you to stop sharing the screen, Leo, which should put us back up as the main focus. At this point, we'll run through some of the questions that's come in from the audience. I'll obviously ask the questions. You can read along, as we mentioned, through the Q&A. Whichever of you feels most comfortable, or both of you to answer, by all means, just jump in. So I'll run from the top. I've even got a couple of questions myself. They're bound to be the most taxing for you, I can tell you. So the first one that we've had come in, it's actually anonymous. How confident were you with the human labeling? do you think the 92% precision is limited by inherent ambiguity in the messages? So we'll start with that one first. There was a related question afterwards, but how confident were you in the human labeling?
I mean, we were fairly confident because we did the labeling side by side. So what ended up happening was when I found some weird stumping ones, I would consult Leo and get him to look at it. Obviously, it's not the most efficient use of the time, you know, each one person calling another person to do things that way. So we were pretty confident in that sense. But whoever asked that question does make a really good point in there's still a certain level of subjectivity. So one agent, you know, just from the human condition, one agent might see a message and they might consider it to be out of app or not to be out of app, even though the model has flagged it as out of app. And sometimes we've seen things that the model has flagged as out of app that we think is out of app, but an agent might be like, oh, I can't action that. So there is sometimes some mismatch. It is kind of like an estimate, but a pretty good one.
Okay, and that actually leads on to the related question there. So did you only label the very clear cases, or did you include the possible cases when?
Yeah, I mean, we just sort of took a big old random sample, so we didn't want to bias anyway. So we did have instances of, like I said, the ambiguous, murky cases as well as the clear cases.
Fantastic. I'll jump on to the next one. Again, I'm counting on you two guys just to shout. If you've got something to say, like just tell me. So next question we've got is from Marnie. Good to see you, man. Good supporter, comes to a lot of our events. So yeah, thanks for being here again. Did you come up with any kind of automation process to do the labeling, some human intervention to make sure there's less bias, or was it all kind of human?
Do you want to take that, Leo?
Yeah, sure. So for this kind of, in this instance, we didn't. We used purely human labeling. In retrospect, we probably could have done some kind of like semi-supervised labeling or something like that. But yeah, for this, we were very focused on trying to get out like a kind of MVP first, and then focus on kind of more complex improvements after that.
I will just add to that we did also try one semi-supervised algorithm, iterative labeling, so self-labeling, where excuse me, you give the model, you know, a tiny bit of label data and you then send it off to label something by itself, but it didn't really come back very fruitful. But then again, it's quite a basic form of semi-supervised learning.
Fantastic, sounds good. Just a shout out to the people still watching as well. As I mentioned at the start, you can upvote. So we've now got 13 or 14 questions sitting in a queue. If any look particularly good, you can upvote to get them towards the top. So we'll stick with that top one there again from Marnie. How do you make use of the metrics you get from the system or processes? Do you back propagate? Oh God, I shouldn't have said that upvote now because it's jumping around all over the place. Do you back propagate back to your model data to find out what might have led it to to pick it basically as a possible source of out of app?
We pretty much just, and feel free to jump in, Leo, we pretty much just used the metrics as a form of validation. So whether to understand whether it's something that can be put in production. There isn't really much back propagation there, though we are working on something similar that might help us do that in the future.
Okay, fantastic. Question from John Howard. A very good question, actually. How comfortable are the users that their message are being analysed and reviewed? Do they view it as a safety feature, or do they feel a bit like Big Brother's watching?
So I would hope that they're comfortable with it, because at the end of the day, I mean, we are the trust and safety team. So what we do is with the user's safety as our primary interest.
Yeah.
I can say that out of app is probably a reasonably significant risk to a user. Mm-hmm. So I think I'd hope that they're comfortable with that.
Yeah, makes sense. But what's the long-term plan? Obviously, at the moment you're flagging it, and then it goes to a different team where there's human intervention and stuff like that. Do you think you'll get to the point where you auto label like like Facebook does with fake news, or do you think you'd perhaps even put a block on someone's account until it's been checked? Do you think you'll ever get to that point where you make an automatic intervention?
So, do you want to take that?
Go for it.
So, the idea with that is the messages are anonymized. So the model doesn't actually know whose message it is, and neither do we, the labelers or the people looking intervening. So the idea there was is to surface as soon as it happens. So while picture you're sending a message in the app, you send or you receive an alphabet message. So on the app, it would be nice if it were to be the message was blocked. So it was like obfuscated, and then the user then had the option to unblur it or unblock it. So I guess that's kind of the longer term.
Okay. Perfect, thank you. Martin's asking, do you keep retraining and refining the model with data from previously missed predictions?
So not at the moment. We have like a long-term view that we would like to be able to do that with our models, but yeah, as I said, this is kind of very MVP, so that kind of thing is not, we don't have that capability at the moment.
Okay. And talking about it as an MVP, what's been the business impact from it? Has it been well received? Is there noticeable improvements from rolling out this new feature, new product?
Sure. So I mean, it's great for our moderation agents because they can now effectively moderate for this kind of behavior, whereas before it was extremely difficult to near impossible given the amount of alerts that were being flagged by just naive keyword tagging. So yes, it's a great business impact.
Fantastic, sounds good. Marnie's asking, can you recommend any open source tools or libraries, other resources that we could use that you've come across in, working on this product and these projects?
I found some really good open source tools for collaborative labeling. I can't quite remember what they're called now, but if you get in contact with me, I can let you know. So yeah, there are definitely some open source tools for collaborative labeling. As well, Bert is open source, so Google have a repository on GitHub with various sizes and configurations, and all you have to do is pretty much just download them and plug and play. There's another open source. There's this company called Hugging Face, and they make open source code, and they've got these open source libraries that implement loads of different transformer architectures, from vanilla transformers to XLNet to Bert, and so those were all pretty useful. Leo, do you have any that come to mind?
Probably none that you've already covered, to be honest.
Okay, man, we can follow up afterwards actually, and maybe put that in a little message across the attendees, so that's cool. Question from Paramdeep. Could you give a little bit more information on the deployment of the model itself? Is it making predictions via REST API or something like that?
Sure. So the model is deployed in a Docker image and runs in ECS. It's not like a RESTful API. The model subscribes to a messaging queue, and our backend publishes messages as users send them through the app. Our model consumes those messages, does whatever, does the inference on that, so predicts whether or not it's out of app, and then publishes it back onto the queue, so that our downstream tooling can then consume those predictions and do with them what it will.
Okay, thank you. Michael Bateman is asking, did you try Snorkel or Prodigy? I'm hoping that means something to you guys.
No, we did not. We just sort of, like I said, it was just sort of a MVP sort of put together approach.
Yeah, cool, thank you. Thomas is asking, have you seen a change in the type of language used by the sellers in order to try and avoid the flagging?
Yeah, that's a really interesting question, and I guess whenever we are looking at machine learning in this kind of area of trust and safety, there's always this concern that users will learn how to gamify the AI and circumvent it. In terms of what we've seen so far, I personally haven't seen a huge change in language. I would expect that some users, even before we did this, were suspicious of us moderating chat, and were trying to use like special language to circumvent whatever tools we had in place. But yeah, I haven't seen that since we deployed the model, that kind of thing.
Okay. I will add to that so we previously worked on a fake model, so a model that detected whether an item was fake based on its description, and some other features. But I will say that I've noticed that a colleague of mine brought it to my attention that recently people have started using the word booty instead of bootleg as another way of saying something's bootleg or fake. So it's definitely, like you said, it's an interesting question, something that definitely does happen, but we haven't seen it yet out of that.
Perfect, thank you very much. Quentin's asking, how long does it take the moderators to take action? Do you think the action is quick enough to prevent out of app actions?
I'm not sure, so it kind of varies. Because our trust and safety agents are not only looking at out-of-app issues, but like I mentioned earlier, fakes, as well as a myriad of a whole ton of other things. So they kind of react, they're a whole team, they kind of react as and when and how needed. So if, there's an influx of scams or fake items, they kind of direct their, manpower towards that. And there's less people working on out-of-app. So yeah, the timescale sort of varies depending on what's going on in the app.
I imagine they're kept very busy. So as we are with you guys, so we're like really flying through some of these questions. It's a bit intense, but hopefully you guys are coping okay with it. So Ivan is asking, what does the update process look like, feeding back knowledge around false positives and true positives as a path to improvement over time? So as you've mentioned a couple of times, it's an MVP. Are you constantly improving and, improving the product?
So we work in as I said, we work in like a cross-functional team, but we also work very closely with our stakeholders. So that's the trust and safety agents who do the moderating. So any feedback they have in terms of what they're seeing being flagged, if there's like particular patterns of certain kinds of messages being erroneously flagged, we can take on board as a team and adjust our roadmaps accordingly to meet their needs.
It's good. I think you've probably won half the battle getting them on board. You've probably made their life a little bit easier, which gets a bit of buy-in, I would imagine. It makes things a bit easier. Sebastian's asking quite specific questions around how much is lost and stuff like that. If there's any questions that you feel unable to answer from a business perspective or whatever, just again, flag it. But Sebastian was asking how much is lost to out-of-app behaviour? What improvements have you seen as a result of your work for Depop? Less money lost, less complaints, happier users? What's been the overall outcome with the app?
I mean, before starting the project, we did some exploratory data analysis to sort of estimate what the impact. So we first estimated the GMV lost as a result of out-of-app. So, and we sort of calculated that based on the sale was somebody listed an item, they started talking about the item, and suddenly the item disappeared, but we didn't get any money. So we used that to estimate how much GMV we're losing. I don't really know if we can share those numbers.
It's
so
probably sensible.
I will say that we did estimate how much GMV we would gain back as a result of the model, and it sort of, it justified us building the model, so it was a pretty decent amount.
And I'm guessing if someone does go out of app and purchase something, do they then come back to you and complain if it doesn't turn up?
Yeah, that's really the biggest pain, to be honest.
Yeah.
You've got like signposts across the app that are like, you know, you're not protected, you know, you will get scammed, but yeah.
Okay, fantastic, thank you. Next question from Dimitri. How long did it take you, you know, to build this MVP?
So we spent kind of just under a quarter building out 3 models. So that's including like labeling, training, and delivering like an end-to-end productionized solutions. Mm-hmm. Specifically for out-of-app chat, maybe it took us maybe a month, I want to say.
What's the team structure? How big was the team? Was it engineering and scientists, product people? What did the wider team look like?
So it's a cross-functional team. So we've got myself and Odie as data scientists, a few, like 3 or 4 back-end engineers, product manager, product analyst, delivery manager, tech lead. Yeah, and in terms of this project specifically, like it was a data science project, so it's just me and Odie working on it. At Depop, data scientists own their projects end to end, so we work on all of the productionization for that. So it's yeah, in terms of structure, it's me and Odie working on it basically.
Perfect, well done. Question from Adam. What other transformer architectures did you try? And were there any other reasons for choosing Bert besides performance?
So we tried, the big 2 were Bert and ExcelNet. I've already talked a bit about Bert, but ExcelNet, so Bert sort of, and transformers in general, sort of do over recurrence and opt for attention. So they're like consuming everything at once and picking what to pay attention to. ExcelNet does the same, but then adds back in recurrence. So it's like attention plus recurrence. So it's at least a really Excel nets, like really big networks. We found that it was slightly better than Bert, but in terms of its like size and complexity, it just didn't, the marginal increase in classification performance didn't justify the operational complexity. So yeah.
Yeah, okay. And mate, talking about that then, you mentioned kind of 2 million messages a day. You know, how does the model handle peak load?
So we, in terms of, well, I mean, in terms of the load, it handles it, but we use ECS to deploy our models. So that means that when we're at like a really peak time during the day, our cluster can auto scale, and we can provision more resources for the model when that happens. Likewise, when it's not so busy, it can scale down.
Okay, thanks very much. Question from Doug Ward. Are you planning to run any further analysis on content of messages for other facets of Depop? So is there wider messaging that goes on within the Depop app that you can start to put this model against?
So, I mean, so we kind of just have messaging in the messages functionality, but we also have things like comments, which just aren't largely used. We've got comments and we've got listings, and I guess people can put text in their bio. So like Leah mentioned in the beginning of the presentation, we have also got models that look at all of these things as well. So we built out 3 separate models, one that looked at the chat messages, and then 2 other models that looked at the listings or whatever people write when they list a product and whatever people write in their bios. I'm not sure if that answers that question.
Okay, no, that does. Yeah, thank you very much. We're probably on course for some sort of record here, guys. I think we've done like 15 questions already, and there's still a few more. So I'll just talk slower and then give you guys a chance to cope. We've got another question from John Howard. He was talking about your earlier solution. So with the original solution, what was the rate of false positives for the non-machine learning solution? And then once you'd applied the machine learning, what was the improvement afterwards?
Oof, off the top of my head, I don't actually know. Odie, do you have an idea?
No, I don't, but I know it was pretty much quite high. It was, I think Adrian probably said it was like near, like borderline, like 50-50, like in terms of, 50-50 it being alpha app or not.
Yeah, okay, cool. Marnie's asking, are you using the models directly, or are you doing some sort of transfer learning using your own data?
Yeah, so we are using transfer learning. So we got the pre-trained model, and then we then fine tune it on our label 20,000 messages. Yeah, that's exactly what we're doing.
Cool. I'm going to skip past your next one, Marnie, because you've asked quite a few, and then we'll come back to it. So, Martin's asking, did you experiment with using hosted cloud auto ML services like Amazon SageMaker, Lambda, or similar in Azure, rather than running a custom model inside Docker?
So we didn't use kind of AutoML for this project. We do use SageMaker, and we did use SageMaker's hyperparameter tuning jobs quite extensively, which we found to be pretty good. Yeah, I mean that's kind of the extent to which we used it. Odie, is that?
Yeah. Pretty much it.
Cool. Belinda's coming in with a bit more of a business focused question. So again, if you can't put an exact number on it, like don't worry, guys. But she was talking about, again, in terms of the value that you've saved the business. Have you got a rough idea of how much you've saved, Depop?
I wish we could share, but
I should have just not asked the question, shouldn't I? I can't resist it, just in case. Sorry, Belinda. We tried. Next time. I'm guessing you two guys have more than paid for yourself for the foreseeable future, though, which is probably a good place to be in. Anna is asking, do people who try to go out of app normally try to reformulate their out of app offer when their message is blocked? So basically, do you see people coming back and trying again once you've caught them once?
Sometimes we get sometimes we get repeat offenders. So the way it kind of works is once we catch these messages, the model catches these messages and surfaces it to our agents. Our agents then check, and if it's your first offense, you get warning. I think you get about 2 warnings, and then you're banned. So sometimes some users do get multiple warnings because they just, I guess, flagrantly just like flout the rules. So we do see people coming back, but they don't. I don't know if it's that they don't change the way that they do it, or they're not able to change it substantially enough that the model doesn't catch it. But either way, we do get some bad actors who do it multiple times and they get banned. Yeah.
Okay, fantastic. I'm going to jump to the question from Martin. Martin was asking that for conversations in the app that span across several messages, several chat exchanges, do you refeed all of the previous content into the model, or do you only feed the most recent message?
So that's definitely something that we thought quite extensively about when we were starting the project. We concluded that basically, because this is an MVP approach, the solution should be to look at individual messages first and see what difference we can make with that. But yeah, that's a really good point.
Cool, thank you. Well done, Martin. When they put that into the next version, you can take the credit for that one. We've got two questions left. I'll just quickly go to the question from Harmons. I'm not sure if this is going to apply to you guys, because like you guys obviously don't necessarily have your own stock levels and stuff like that, do you? It's other people selling their products via your exchange. So I think in terms of that question, Hamid, we'll maybe skip past that one because it doesn't quite apply to Depop. And then we're going to finish up with Marnie. Clustering could have helped with the human intervention as well when doing manual labeling. Is this something on the pipelines to improve the process? So we kind of half talked about it a little bit earlier, I guess, as well. But are you planning to continue to look at labeling and bringing in different features to label the data?
I mean, so I guess we're mindful of data drift. So in time, if language changes substantially enough, the model will probably give less returns, or perform less, and we would then need to retrain it. And at that point, we do want to, I guess, look towards better ways of labeling. We haven't currently considered clustering as part of our labeling methodology, but I don't see why not, to be honest.
Cool. As I say, I do feel like this is possibly some sort of record. I think we've done, what, 22 questions there, guys. So quick fire, and you don't look like you've even broke a sweat. So you've done very well there, guys. So we're going to draw it to a close for this week. Obviously, from the community, from the Data Science Festival, I'd like to thank you very much. Hopefully you guys have both enjoyed being part of it.
Yeah, thank you for having us.
Perfect. Well, thank you very much, everybody. We'll be back next week, and yeah, look forward to seeing you all again soon. Goodbye.